Okay, so we're going to do a unit step function example. So this is the same thing as the heaviside function for our forcing function. And let's look at the same differential equation we've used before. We have x double prime plus 4x prime minus 21x. We've got that part. Now we'll do the unit step function that jumps up at 3, t equals 3. And we have the same initial conditions we had before. x0 equals 1 and x prime 0 equals 0. So we do what we have been doing. We take the Laplace of everything, but I'll do that linearity part right away. So plus 4 Laplace of x prime minus 21 Laplace of x, like that, and Laplace transform of that unit step function that starts at 3. Okay, so I take the Laplace transform both sides. Again, this is just x squared big X, so that's the uppercase X, minus s, x at 0, minus x prime at 0, and then plus 4 times all of this stuff, s big X minus x of 0, like that, and then minus 21 big X, and equals, and again we look up that Laplace transform from this section, and we get e to the minus 3s over s. Now I'm going to shorten this a little bit because we've done that before. I know that this, when I plug in my values for x0 and x prime 0 and so forth, and pull things together, I get the s squared plus 4s minus 21 all times the Laplace transform of x equals, and then we had the minus s and the minus 4 on the other side, so I brought those over, plus e to the minus 3s over s. Okay, so then factoring and dividing. So we factored this thing before, and I'm going to call it s plus 4 over s minus 3 s plus 7, and then plus e to the minus 3s times 1 over s times s minus 3 and s plus 7. Okay, so this I've done before, so I know the answer to that, and what I'm going to do is add a page and come over here and take care of this part. I'm not going to worry about the e to the minus 3s. Okay, so I have 1 over s times s minus 3 s plus 7. That needs to be sum a over s plus b over s minus 3 plus c over s plus 7. When I get that common denominator and so forth, the numerators end up being a. 1 equals a times the s minus 3 and s plus 7, and then plus b times s plus 7, and then plus c times s minus 3. And so again, if we let s equal 0, what that means is that a is equal to 1 over, and I just put 0 into here and here, and I get minus 21. Then if I let s equal 3, that implies b is equal to 1 over, I get 3 times 10, so that's 30. And s equals negative 7 implies c is equal to 1 over, well, let's see, I got a negative 7 there and a negative 10 here, so positive 70. And so I can write that fraction as minus 1 over 21s plus 1 over 30 s minus 3 plus 1 over 70 s plus 7. So that's that partial fraction. I go back here, so x is equal to, and I'll do my previous partial fractions from that one, and that was 3 over 10 times s plus 7 and plus 7 over 10 s minus 3. And then I have plus, well, actually I guess minus for that first one, e to the minus 3s over, and that was, I believe, 1 over 20, yeah, negative 1 over 21. So 21s, and then plus e to the negative 3s over 30 times s minus 3, and plus e to the minus 3s over 70 s plus 7. I think I got those in the right order. Yep. Okay. So that's x, and now I need the inverse Laplace transform, and so we have x of t equals. Now again, on the inverse Laplace transform, I know how to do those first two. We had done them before, and so those first two are just the 3/10 e to the negative 7t, and then plus 7/10 e to the positive 3t. Okay, so we've got those two taken care of. Now we have to do this other stuff. Well, here, this is just negative 1 over 21 times the Laplace transform of u3t, right? Because there's a Laplace transform of u3t right there. Sorry about that, kind of moved that. You know, there's, right, there was u3t, I took its Laplace transform, got that. And so I know this is just minus 1 over 21 u3t. Now the others, what we need to use is, and maybe the thing to do is to go over here, we need to use the uct f of t minus c. When I take the Laplace transform, that becomes e to the minus cs f of s. Okay, so how do we use that? Well, so actually I know that each of these right here, this one, they are multiplied by that e to the minus 3s. And so I can tell you that c equals 3, right, because the minus is already there. So c is equal to 3. Then what I have for my f of s, for instance in this first case, I have the 1 over 30 s minus 3. Well, I know how to undo that. That is no different than my other one, where f of t, when I do that inverse Laplace transform, is just 1 over 30 e to the 3t. And so similarly for the 70, I will get, you know, the big F of s is the 1 over 70 s plus 7. So that means little f of t is 1 over 70 e to the minus 7t. Okay, but notice what this says is it's t minus that c, so t minus 3. So what I'll need to do is come down here, and f of t minus 3 is 1 over 30 e to the 3 parentheses t minus 3. That's important. And then here, when I do that same thing, I get 1 over 70 e to the minus 7, and again parentheses are important, t minus 3. And so I'll put those two back here. So I come back here, and so the answer is plus 1 over 30 u3 of t, and then my e to the, let's see, which one was the 30? That one was the 3, so e to the 3 t minus 3, and then plus 1 over 70 u3 of t e to the minus 7 t minus 3. Okay, so there's my solution. Now, actually, this u3t, again, remember, that's just the unit step function that says, okay, that's 0 until I hit t equal 3, then it's 1. And so, this is just a fancy, a nice, I'll call it straightforward function writing way. To do this is that this is x of t, and it's simply the 3/10 e to the negative 7t plus 7/10 e to the 3t whenever 0 is less than or equal to t strictly less than 3. So I'm going to get that out of there. But then, once we hit, once we hit 3, we have that whole big thing. So we had this again. So we have our 3/10 e to the minus 7t plus 7/10 e to the 3t. Then we have minus 1 over 21, and notice I got rid of the u3t because here we're going to be t is greater than or equal to 3. So minus 21, whoops, minus 21. I don't, you know, I think I finally just figured out why that's doing that. I think I get my left thumb over this thing. But now we have the 1 over 30, so plus 1 over 30, and that was the e to the 3t minus 3. And then finally, right, yep, okay, and then finally 1 over 70. So plus 1 over 70 e to the minus 7 t minus 3. And so that's quite a bit, but that's what it is. We just have this piecewise defined function. Up here in the top part, that was when things were 0 on the right hand side, or no, it was homogeneous. And then once that Heaviside function or unit step function kicks in and we have 1 on that side, then the solution looks much more complicated. But we're going to look at this next in terms of how we would have solved this in Chapter 4, just to show that we can do something like this without the Laplace transform. But what's nice about the Laplace transform is it kind of takes care of everything all at once. It's still kind of nasty, but each part is really not too bad. Okay, so there's our solution using the Laplace transform with a Heaviside function at the right.